This is a Technicom podcast.
5G. It's become a buzzword, a marketing term, maybe even a sales gimmick. But behind all the glitz and glamour of the promised tremendous data speeds and ultra-low latency are the people making it happen. And here in Europe, it's H2020 funded projects that are enabling this research. I'm Peter Ballant from Technicon, and today we look at one such project called SERENA. SERENA partners are exploring the use of high frequencies for data delivery. And the higher the frequency, the shorter the radio waves are able to travel. So they must travel smarter. And this is where beamforming and new types of antennas are coming in. Using gallium nitride on silicon as a means to develop high-performance millimeter wave active antenna systems at a commercially viable price point while remaining energy efficient is at the heart of SERENA. Today we talk with SERENA partners Giuseppe Caira and Thomas Kühne from the Technische Universität Berlin. Let's have a listen. Welcome, gentlemen, and thanks for coming on today.
Great.
Yes, thanks for the invitation.
Yeah, thank you.
In the intro, we heard a bit about the big picture in SERENA, but what is your particular role in the project? And we'll start with you, Giuseppe.
Yeah, so basically SERENA is a large project with many partners. We cover the signal processing part. And the signal processing part consists of basically what comes after the antennas and the A to D converters and take the signals and basically make sense out of them.
And to clarify for our listeners, when you say A to D converter, that means simply analog to digital. Thomas, can you add anything here?
Yes, so the part of signal processing is not only the strict designing the signal processing, but because of we are so many partners and also from different fields of expertise, it's also our task to basically help designing the overall system and say what requirements the signal processing has on the other components, and also what is the limitation of the signal processing so that the others know what they can expect. So it's also on the collaboration side that basically we discuss it together in the project, and it's our task to basically present the signal processing and the communication system.
So your team is basically managing expectations when it comes to signal processing. And this is important because nothing happens without the signal getting through, regardless of hardware or anything else.
Yeah, actually, the signal processing involves going from the digital domain to the analog domain, and therefore at the transmission side is generating waveforms that will be then amplified, filtered, and sent through the antennas. And on the other side, on the receiver side, is collecting the signals from the antennas, filters, and eventually A to D converters, and then somehow transferring them into a digital machine that does the numerical processing of the signals, and therefore analyzes, decode the signals if this is a digital communication. But anyway, does the measurement, the representation of the signals that come from the hardware. So without that, the hardware is difficult to understand what the hardware does if you don't see the signals. Eventually you can actually process them and make sense out of them.
So maybe in general, for more customer viewpoint, what the signal processing does is it converts the bits from a video, for example, and converts it to this analog signal, which is then used by the hardware to be transmitted. And this conversion process it consists in general of many steps, and some are related to communication systems, and we are basically covering this communication steps. And the better we do that, the better the communication is. So the more reliable and the higher the data rate is.
Yeah, reliability and speed from the consumer side, these are the top issues. And working at higher frequencies gives us increased bandwidth, thus faster communication speeds. But tell us, Giuseppe, about the challenges or downsides of working with these higher frequencies.
Yeah, so it is very challenging because there is something called the propagation loss that depends on the wavelength. So the smaller the wavelength, and therefore the higher the frequency, the smaller the wavelength, the larger is this propagation loss. And this propagation loss has to be compensated through antenna gain. So antenna gains means that one has to design, in this case, in the case of SERENA, smart antenna arrays that create something called beamforming gain. So the antennas becomes very directive, and in order to achieve this directivity, basically, well, there is all the digital and analog processing that creates that. So it's not only a problem of amplifying the signal, but it's also creating these special antenna radiation patterns that can be steered towards the target. And of course, this presents a number of problems. So the technology problem is to design efficient hardware and algorithms to do this beam steering. And on the also there are problems in terms of network design, because one has to design particular transmission patterns and that allow the base stations and the users to estimate directions and point beams at each other, which is a fairly difficult process, especially in mobility conditions where beams have to follow the target. In addition, high frequencies suffer from blocking problems, so they don't go through walls. They don't go around buildings like lower frequencies do. So it means that you need probably a more distributed, a more dense deployment of access points in order to have to guarantee coverage. So there is a number of challenges at the system level, at the technology level, and at the algorithmic levels that make the exploitation of very high frequencies still quite at the beginning, and the direction of 5G and then beyond 5G is to go higher and higher, and so to address these issues.
Yeah, and I think one of the major challenges or the downsides is that this technology is very new. All what Giuseppe said is true, and that's why you need those new technologies. But one has to understand with 5G is the first big standard who actually introduces these high frequency into real products. It has been there before, but just a couple of years ago, and was more Wi-Fi systems, but it hasn't been used. It never really took off. So where the lower frequencies have been used for 20, 30 years, and with radar even longer in commercial systems, this is the first time where those technologies are used in commercial systems. And that's what is challenging in actually using those. So the downside is that the experience is much lower, is much less experienced than for higher frequencies.
That's a good point, Thomas. I would imagine that without decades of performance data or real-world experience, working in these high frequencies could be quite challenging. What do you think SERENA can contribute to the 5G world of tomorrow?
It's actually not maybe a single result which SERENA will have, but SERENA is a project with many partners, and it's actually bringing together different technologies to basically solve this common goal of having an efficient high frequency system. And it's also the interesting part of SERENA is that there is this cooperation between the many partners. And for example, we have some partners who focus on manufacturing, and some focus, like we are, on the signal processing. And basically all our results are a bit hidden from the customer, because what we will enable with this cooperation and basically that we design a system which has all of these different fields in mind is that we have a more efficient system, so the power consumption might be better, and also have a higher integrated system so that it's actually feasible to be implemented, so that 5G can have many of those millimeter wave or high frequency base stations, and not only a few, because if they are costly and if they use a high power, maybe there are a few, but if they're really up to date and they don't use too much power and they are cheap enough so that they can be sold with a profit, then they are actually deployed by the providers.
Meaning these marketing aspects must be considered even in the R&D phases. Giuseppe, do you have anything to add?
I generally agree that the SERENA platform is a high output power steerable antenna array at millimeter waves that is highly integrated, and therefore it's like a step forward in bringing this technology to become mainstream in terms of cost and usability. Then we have to see how especially the industry partners in SERENA will decide to do, and this will evolve into real products. That's maybe a bit early to say, but certainly that's the direction.
That would certainly be a great result coming from SERENA. Giuseppe, sometimes in the field of communication, we hear of beyond 5G. Is it clear what beyond 5G will actually be?
Yeah, so it's funny because 5G is barely being deployed, and the component of 5G which is deployed is mainly the core network and some software features and some radio access interfaces at relatively low frequencies. There is not yet, as far as I know, apart of say beyond lab experiments, there is not yet a widespread deployment of millimeter waves, at least for the access. So for the access to the users, people use millimeter waves for relaying macro base station to smaller base stations to do like a wireless front haul and things like this. But for access, for coverage, is still pretty much not yet there. Nevertheless, industry and research are already thinking about beyond 5G. Some people, there are 6G centers, 6G research hubs popping out in different European countries. So I think that the definition of beyond 5G is still quite vague. For some people, this means going even to higher frequencies than millimeter waves. Other people talk about a different type of features, the ways of going beyond cellular. People talk about cell-free, user-centric networks that go beyond the concept of cellular. There is this concept of open RAN architectures with interoperability between the different vendors, so that the telecom operators are not somehow committed uniquely to a single vendor that provides the whole set of network components all together. So there are many different ideas that are in the discussion. So I think that the contribution of SERENA in this direction will be somehow demonstration and feasibility of the steerable antenna technology, which although it has been around for a while, is not particularly new in terms of the concepts, but has been relegated mainly in military applications. So phased arrays in military applications, they are very expensive objects, or on research papers.
Maybe I can also add the larger part of SERENA is investigating frequencies which will be used in 5G, and the 5G which might be deployed in a year or two. But there's also a smaller part of SERENA which actually focuses on even higher frequencies. So exactly what Giuseppe said, that one technology or one idea for the beyond 5G world is that even using, again, higher frequencies because of more available bandwidth. And SERENA even covers this. I mean, it's not as integrated and not as complete as the 5G part, but there is already a part of SERENA which investigated those higher frequencies. And of course, also the signal processing and the design of the communication system we have proposed with SERENA might become more and more relevant for higher frequencies because it becomes more and more different compared to lower frequency systems. This is also something which can be used for higher frequencies, or which even has to be used more and more for higher frequencies.
And that's most encouraging. SERENA has been running for almost 3 years now. What kinds of challenges have you experienced in that time frame?
So what I have mentioned before, what the goal of SERENA is to integrate many partners and many fields of research. But of course, this can also be challenging because collaboration is something which needs to be done. And then you have experts from different fields. So there's often a bit difference in seeing the problems from different viewpoints. And this collaboration, it was actually a very good collaboration within the project, but it still, the partners have dependencies. And those dependencies are a risk when you see that there are some delays introduced because maybe something didn't work out as expected in the beginning. So delays were somehow a problem for SERENA because it's still research. So things cannot work, and then they might need to be redone with something you learned in the first process where it didn't work, and then the second version works. But then maybe you have a partner who is also delayed because he also needs to wait for the second version. So the challenges have been exactly in this collaboration that partners depend on each other, and this means that delays propagate and things cannot be tested before a certain goal has been achieved, and things are tested from a different partner. So that was basically the main challenge, I would say. But it was also, this collaboration is, I think, at the heart of SERENA, so it's very important, but it was also a challenge and a risk. But sometimes you, especially in research, you need to take risks, otherwise you cannot go beyond the state of the art.
Yeah, I think that I don't have much to add to what Thomas said. Is that in these multi-partner projects, it's always challenging to make all the partners work together in a way that at the end the integration can actually be done without too many problems. And also there are several different technologies here in that participate, and so yeah, there were some challenges in putting all these things together.
Well, that's how it is in the research realm.
Yes.
So on the SERENA website, I see that there is a demonstrator to be built. And seeing as how we're on the tail end of the project here, can you give us a brief update on that endeavor?
So actually, we can see the demonstrator is built from many blocks. As I said, we have many different partners. And the main achievements of the project, so this manufacturing integration and the communication system, those work. So we have a demonstrator for this very small integrated module where you have the antennas and the power amplifiers and beamforming all integrated, and we can also control this module. So this is the basic block of what how the proof of concept system, as we have called it, is envisioned. And this module works, and we have also used it to measure communication signals and to see if the signal processing works. What is a bit delayed because of the challenges, what we have talked before, is that we use this block and we basically scale it up to have a nice demonstrator which is already into the direction of a product, which is of course not a product, because with a product you need to support and things like this. But we want the goal was to have a demonstrator which could actually demonstrate the whole system on a large scale. And this is unfortunately a bit delayed, but all the working parts, they work, and we measure them and we got the results. So let's say for the research, the important parts, they are there and we have demonstrated them. Whereas the final demonstrator to show maybe to the public, which is easier to understand, is still delayed, but we are working on it.
Well, this sounds good, and progress was made, and the results of SERENA could keep Europe on the cutting edge of next-generation communication. And this is, of course, undoubtedly due in part to the efforts of both of you. Thanks for all the information about SERENA.
Yes, thank you. Thanks.
Okay, thank you very much. It was a pleasure.
This podcast was brought to you by Technicon. The SERENA project has received funding from the European Union's Horizon 2020 Research and Innovation Program under Grant Agreement number 779305.